All right, so we're going to continue along our rational models discussion here. One of my cats has the zips, so if you hear the trampling of elephants in the background, that's just one small cat. Okay, so I'm going to go ahead and cover up this other one so we can concentrate on this first one. Okay. It says James has a pool in his backyard. If he uses his hose to fill the pool, then he can fill it in 30 hours. Amelia, his neighbor, has the same pool, but she can fill it in 24 hours. Suppose Amelia allows James to use her hose in order to water the pool. How long will it take to fill the pool with both hoses? Okay, now you can't just add these up, because if it takes James 30 hours, then why would he have, that's delightful. Why would you have to add 24 hours to that? So it's got to be some kind of combination between the two of them. You can't average them, because if you average the two of them, look, all right, we'll go ahead and pull this together. So we've got 30 plus 24 and divide it by 2, right? And at that point, you'd say, well, you know what? I'm just going to use Amelia's hose and get it done in 24 hours rather than the 27. That's their average. So it's got to even be shorter than that, okay? So let me just start us off on the kind of a numeric idea here. And we'll just go off and we'll make a little chart. We'll say, here's the number of hours. Here's the amount filled. So we have James's hose. We'll say amount filled. Okay. And then we have Amelia, and then we'll have amount filled. And then we'll do a total over here. Okay. So in the first hour, if James's pool is working alone, he would have filled 1/30 of that pool. Does that make sense? Right? If you can fill it in 30 hours, then after 1 hour, 1/30 of it is going to be filled. Amelia's hose, so if he strung this hose over from her house and filled up his pool with it, she would have gotten that same pool filled in 1/24 hour. 1/24 of it is going to be filled up. So after 1 hour, we have James plus Amelia, and I'm going to go ahead and be extraordinarily lazy about this and say this is 1/30 plus 1/24, and we end up with 0.075. Okay, so 0.075, let's go ahead and call that as a fraction. Okay, so we have a total of 3/40 of this pool has been filled up after 1 hour. Okay. Let's take a look at what happens in hour 2, right? In hour 2, then James's hose would have filled a total of 2/30 of that pool. Okay? When he gets to 30/30, he would have the whole thing filled. Okay, plus, and we're going to have 2/24 here. Now we're going to add those together. Okay, we're just going to say, what is this equal? What is this equal? And we'll say this is 2/30. Okay, plus 2/24. You guys can see that, yeah? All right, and then we'll go ahead and do that. And again, I'm going to be really lazy about this and go ahead and say math, turn this into a fraction. And we have 3/20 or 6/40. Okay, 6/40 or 3/20. So in the first hour, 3/40 got done. Second hour, 6/40. The third hour, I'm going to go out on a limb here and say that this is going to be 9/40. Okay. Let's go ahead and check that. So we're going to have 3/30 plus 3/24 in equals. And let's see if that's actually working out here. So 3/30 or 10th plus 3/24, okay, or an eighth. And let's go ahead and change that to a fraction. All right. Hey, look at that, 9/40. And I'll bet you could fill in the rest of this table, because I have a feeling you sense a pattern here. Okay, that's not really how we want to do this in algebra, because if we really need to, we can make a table that would take you from now until we all die of old age for you to finish. Okay, so what's changing between one row and the next row? And that would be the hours. That's our time. Okay, so rather than fill out a table for this, why don't we just let that be a variable and say t/30 plus t/24. And looking at this, how do we know we're done? right? We're looking at 3/40ths of the pull in the first hour, 6/40ths in the second hour, 9/40ths in the third hour, dot, dot, dot. Eventually, we're going to come up to some number that's 40/40ths. So we're done when you filled up the pull. When you have 100% of the pull, or 40/40ths of the pull, which is also a fancy way to say 1, okay, that's how we're going to know we're done. Hey, look at that. We have some kind of an equation. We've got a t here. Everything is looking pretty good. All right. So I'm going to go ahead and not be incredibly lazy this time and say, well, 30 is, right? 30 is 6 times 5. 24 is 6 times 4. What if I multiply by 4 times 5 times 6 for the whole thing here, right? 6 times 5 is when I visit over here, okay? We're going to have 6 times 5. That's going to cancel with the 30, so we're going to have a 4t. When I'm looking at the second term in this common denominator visits this, the 4 and the 6 cancel with the 24. That's leaving a 5t. And then on the other side, this doesn't cancel with anything. So we've got 4 times 5 is 20. 20 times 6, that's going to be, or 30 times 4, that's going to be 120. Okay. So however you multiply that out. Then we could just solve this. All right. We're going to have 9t is equal to 120. And then divide both sides by 9. Divide both sides by 9. And we have t is equal to 1/29. What is this? This is 3 times 40 divided by 3 times 3. That cancels off. 40/3. So just to give us a numerical approximation here, 40/3. 13 1/3 hours. Okay, 13 hours. 1/3 of an hour is 20 minutes. Okay, so if they both fill the same pull up, right, rather than taking 24 hours, rather than taking 30 hours, they'll get this done in 13 hours, 20 minutes. Okay, so that's how you do a problem like that. All right, let's look at one that's a little bit different. All right, this will be the second problem that we have here. Move this up. Am I in frame here? Are we good? We're good. Okay, so we're going to say, suppose a faucet can fill a sink in 5 minutes. The toddler has partially blocked the drain, so it will drain an empty sink. The drain will empty a full sink, rather, in 8 minutes. Okay, so you see what's going on here. Sink fills in 5 minutes, drains in 8 minutes. Eventually, there's going to be a mess. Okay? If the toddler performs his favorite experiment of leaving the faucet on with a partially blocked drain, how long will it be until the sink is at the point of overflowing? Okay, every toddler loves this experiment. If you were parents of toddlers, you know this quite well, and if you have ever been a toddler, you may remember. Okay. All right. So let's go ahead and see if we can't solve this thing. All right. So going with the previous idea, okay, let me model this out, give it a feel for what's happening here. So after 1 minute, what has happened here? Okay. So the faucet, right, fills the sink in 5 minutes. 1/5 of the sink will be filled, right? Drained. Now, this is kind of a tough one. Before, we had the two hoses helping each other, and helping was a plus. We are going to be minusing for the drain 1/8. Okay, that's what we have for that. And then how long to the sink is at the point of overflowing? We still want this to be like one whole sink. Okay, so we have 1/5. Okay, we're doing 1/5 minus 1/8. All right. And we end up with 0.075. Let's go ahead. I know we just did this one, but let's go ahead and change that to a fraction. So we end up with, again, 3/40. Let's go figure. Okay. Okay. That's coincidence. This is not a common thing that happens. Okay. After the second minute, right, we have 2/5 of it filled. We are subtracting off 2/8 of this. And then we're going to be able to say this is 2/5 minus 2/8 or 1/4. We could just do that. And then again, we are going to have 3/20. Okay, we recognize that number earlier, or 6/40, depending on how you want to say that. And again, I think you have an idea of what's going on here. So what we're going to do is say we have t over 5 minus t over 8, and that is equal to 1. When is this going to be at the point of overflowing? Let's go ahead and multiply by a common denominator here. So the 40 over 5, we end up with an 8t. 40 over 8, we end up with a 5t, and that is equal to 40. 5 minus 8, right? Or 8 minus 5 rather, that's 3, is equal to 40. T is equal to 40 thirds, and I believe that's the same answer we got for the last one. So 40 divided by 3, end up with, yes, okay, brilliant. Same answer. 13 minutes, 20 seconds, because instead of hours, we're dealing with minutes in this case. So it will be almost, right, nearly 15 minutes, a little bit less than 15 minutes, before this toddler's plan of world domination, of filling a sink up and watching it overflow to the delight of him and the great disappointment to the parents who will have to clean this up. That's when this is going to happen. Okay, so forgive me for picking two problems that were very similar numerically, but this is the kind of way you set this up. Okay, when it's helping, you put a plus. When they are interfering, you put a minus. That's the big thing here. If it helps you to start with the table, that's fine. If you're in algebra class, you cannot solve the entire problem with a table. I mean, numerically you can, but that's not the point of algebra. The point of algebra is to kind of find the pattern, come up with an equation, and solve the equation so that you're not just stuck doing a table forever and ever and ever. All right, so I'm going to leave you with that. I'll put a couple of worksheets up. Best of luck with it, and good luck.